I'm partying. I told him we need a like account so I can have this regularly if we're gonna have this the rest of the semester. So he said he's gonna look into it. So I am looking into it right now. So the worst case, if the school cannot pay that $150 education account, I may just buy the regular Zoom Pro, which is $4.99 a month, and then see what I can do about that. But right now, let's just do like this. And then after spring break, we can figure out what to do. And about the exam, so if we don't come back to campus, then I may give you I have to think about how I'm going to give you exam. Maybe we can do Zoom, like what I'm doing. And then this time we're going to open the video so I can see you guys taking your exam. And after you take your exam, you can take a picture and then just email it to me or text to me so I can grade. Okay, so let's talk about your exam when you come back from your spring break. And also I need to do attendance now because administrators want to know whether we're having a class regularly. So they want us to take attendance. So that's why starting today, I'm taking attendance. So somebody, hey, Colin, can I ask you a favor? So can you do the attendance for me and then email me, text me and say who didn't show up?
We're all typing our names in the chat.
I see everyone's been putting their name and everything in the comments as well. So,
because according to my screen, I have 11 students, which including me, be only 9 because I have 2 accounts. So whoever is not here, I need to know so I can do the attendance for the ones who is here and who's not here. Or I guess we can do it end of the class. Okay, let's just wait and see. Or any other homework problems you want me to go over?
No, ma'am.
Dr. Harris.
Yes.
When I put the one with the infinity and like the n equals 1 into my calculator, for some reason it don't be want to, like, I don't know. I'm gonna YouTube it. It's okay.
So whenever you put n equal to 1, what happened? It doesn't let you do it?
It just be like an error.
Or when you put the infinity?
Oh,
yeah, you cannot put infinity. You're right. Okay. So you just need to pick the huge number instead of infinity. If you put infinity, the calculator does not know what to do about it.
I learned that the hard way last night.
Right. So you cannot put infinity. If you want, like, remember when you take statistics class, they have the outer limit is infinity. You don't put infinity, but you put like a 1 million or 1 trillion, just put a huge number. Same thing we got to do with this. Okay, so the calculator does not know how to put infinity. Oh, by the way, you just remind me, don't you not have a summation in your calculator so you don't have to do this by hand?
TI-84 calculators do. So.
Oh, TI-83 doesn't?
I don't know about 83. I know 84 does. I don't have an 83.
Okay, so this problem cannot be too hard then if you just put in your calculator and calculator does your addition or the addition for you then. So in other words, you can just do n equal to like 13 and then you can figure it out in the n equal to n to the 14 and you will see a number and see what the number is. And then see whether the difference is 0.001. Right, so it's not really hard because you do have a calculator that does this summation for you. Am I right? Okay. All right, any other questions from homework that you want me to go over? All right. right, if you don't have any questions, I can do the whole lesson, and after lesson, and you can also still ask questions, okay? All right, so 9.4 is a comparison series. Remember, we're trying to figure out whether this series is converges or diverges. So we gotta have different way to figure out. So remember, we learned doing an integral test. We also learned a p-series. We also learned geometric series. We learned different techniques to figure out whether this series converges or not. So today we're gonna do another tool. So we're learning another way to figure out. So today we are going to learn about direct comparison test. So this is another way to figure out whether the series is converges or not, okay? And then we're gonna do another one, it's called limit comparison test. So this is another techniques that we are learning. So direct comparison test, for the convergence test, developed so far, the terms of a series have to be fairly simple, and the series must have a special characteristic in order for the convergence test to be applied. A slight deviation from these special characteristics can be made a test inapplicable. So we're gonna use different way, which is, for example, in the pairs listed below, second series cannot be tested by same convergence test as the first series, even though it is very similar to the first. This first one, is everybody see it? This is a geometric series. So I can rewrite this problem as 1/2 to the n power. So A is equal to 1, R is equal to 1/2. So this is converges. This series converges because R is less than 1. But this is not, okay? This is not a geometric series. There's another one here. This one is a P series. Since 3, the P is 3, so this word converges. But this is not. Okay, and look at this one. This one, we can figure this one out by using an integral, by saying a u equal to n squared plus 3, and then du equal to 2n. And I'm going to say there's n is there, I can just multiply by 2, and then I will divide it by 1/2 when I take an integral. So yes, I can do this problem, but I cannot do this problem because it's n squared, right? And numerator is also n squared. So if I put u equal to n squared plus 3, du is equal to only 2n, not n squared. So I cannot make du to be this. So I cannot do that problem. Are you following me? Anybody have questions so far?
Can you leave it on that screen for just a second?
Sure.
I took a picture. I got it.
Okay, great. So this is what we're gonna use. There's a theorem. Okay. It's called direct comparison test. So listen carefully. AN is a series and BN is also a series, but the AN is smaller than BN. Are you with me? There's a 2 series, but AN is less than BN, well, less than equal to BN, okay, B sub n. So if the larger series converges, then what can you say about the smaller series? Smaller series is also what? Converges. Are you following me? Because AN is less than equal to BN. If this one converges, then this is automatically also what? Converges, because AN is smaller than BN. Are you following me? because this is very important. That's how we can do the comparison test. Now look at the second one, opposite. It says, if the smaller one diverges, then what can I say about the bigger summation? This will be also what? Diverges. Do you see the order? The order says, if the bigger one converges, then small one also converges. The divergence, you're going to do opposite. If the small one converges, what can you say about the bigger one? The bigger one is also diverges. Did you see the order? The convergence, you want to make sure the bigger one converges, then you can say small one is converges. But the divergence, you do opposite. If the smaller one is diverges, then you know the bigger one is also diverges. All right, is everybody with me? Is everybody in? Okay.
Yes, ma'am.
All right, anybody have questions about
Dr.
this?
Harris. Okay,
Yes.
it's a less than or like A to the N is less than or equal to B to the N. So like if they equal, which one do we use?
Okay, if they're equal, you're right. If it's they're equal, that's the time we have to literally do the other test and see. You just asked me a very good question because it has equal sign, right? So
Yes.
there, in other words, we can have this. So if this is case, if this converges, that means this will be converges too. If this diverges, then what happened to this one? That diverges too. So if they're saying, if one converges and the other one converges, if one diverges and the other one is also what? Diverges. They do exactly the same thing. So you just need to do one test, just do the test on one of them. Then the other one will be what? Same thing. Either converges or diverges. Whatever one does, they do exactly the same thing since they're equal. Okay? Is
Okay.
everybody okay? All right. Can we move? You want me to, is it okay to move on? All right. So let's look at the example. Using the direct comparison test, determine the convergence or divergence of this. All right. This looks very similar to which one? That. Do you agree? Because this one has what? 3 to the n power, and this is 3 to the n power. So this is a very similar series. But we know about this. But we don't know about this. So we're trying to figure out whether this converges or not. So looking at this, okay, this series, look at this. This series has a bigger denominator than this one. Everybody agree? Because say n equal to say 1. This one is 1 over 2 plus 3 to the 1. What is this one? 1 over 3 to the 1. So which one is bigger? Is this, which one is bigger? This or that? 1 over 3 divided by, this is 1 over 3, which is 0.333. What is this one? 1 over 5. What's that equal to? 0.25. So which one is bigger? This series is bigger than that series, isn't it? This is, when you add this number, when you do this one, make it to be decimal, this number is smaller than that number. Are you with me? So in other words, this series is bigger than that series. This is a larger series than what? This is a smaller series. Are you following me? Because
So the one with plus 2 would be B.
So I'm trying to do this comparison. Remember, one is a larger. Okay, one is a larger, one converges. What can I say about the other one? The smaller one is what? Converges. So let's look at this. So we know we know this is what? Larger series. So if this one converges, what can I say about this one? What can you say about this one? If this one converges, what can you say about this one? Yeah, it converges, right? So, but let's look at it. So term by term comparison. So what can I say this? So since 1/3 to the n converges, tell me why this one converges, class. By what? How do you know why 1/3 to the n converges? Why this one converges, class? By what? What have we learned about this? Isn't this the same as 1/3 to the n? Are you with me? I can rewrite the n outside of parentheses to the n. Then what does this one looks like? What kind of series is this? It's a geometric series, isn't it? A is equal to 1, R is equal to 1/3. Since R is less than 1, we know that this series converges. Since this larger series converges, I can say about the smaller series is also what? Converges. Okay, are you following me? Okay, think about it and tell me if you don't understand, you need to ask me again so I can go over this. Because this is if you understand what comparison test is, then it will make your life much easier because you don't have to know everything. You just think about what you know and you just compare them. All right, anybody have questions?
So it's just automatic that if the larger one is converted, the smaller one does as well.
Right, because of this theorem. This direct comparison test theorem says, if the larger series converges, then I can automatically say smaller series converges. I can only do this because of this theorem that we have. Is everybody with me?
Mm-hmm.
So I can also say this: if the larger one the smaller one diverges, then I can say the larger series diverges. So this is a theorem that gave me this power for me to do the work, apply these techniques. Like here. This converges, right? And automatically this become a what? This converges because this is a larger series than this one. This is kind of like a BN. This is like a what? AN. A7. All right, you about to kick out. Okay, so the meeting will be end in 10 minutes. So I will do another 10 minutes and I'm gonna restart again, okay? So do not leave, just stay there, then I just restart in 10 minutes. Actually. All right, so this is what the graph looks like. You see the smaller one? It converges like this. You see the smaller number? It's a 0.7, so the larger one goes right there. The small one converges to where? Right there. They both converges. Okay, any questions so far? Okay, any questions? Can I move on to the next one? Yes, I am recording right now. So I will put this up on a YouTube for you guys. All right, can we move on to limit comparison test?
Yes, ma'am.
Okay, let's do it. So limit comparison test. Remember this one right here. This is a direct comparison test. I'm doing a direct work. Okay, now I'm gonna do limit comparison test. It's the same thing, but I'm gonna do limit. So sometimes a series closely resembles p-series or geometric series, yet you cannot establish the term-by-term comparison necessary to apply direct comparison test. So if you cannot do direct comparison test, that's the time you are going to use limit comparison test. Are you with me? So if you cannot do this direct comparison test, that case, we are going to do limit comparison test. So what does that mean by limit comparison test means? Limit comparison test means, first thing, you need to make sure that your series is bigger than 0. Your second series is bigger than 0. All right, so that's your condition. If you have that condition, you can take a limit. Okay, limit n goes to infinity of both of them. The an divided by bn, it gives you some number L, some number, could be 3, 10, to some number. Okay, L is what? Finite and positive. So in other words, L cannot be infinity. All right, and now, so in this case, okay, when you have that, when you're taking a limit of a an divided by bn give you some number, positive number, then you can say this, either both converges or both diverges. So if I know either one or the other, if I know an converges, then what can you say about the bn? Bn is what? Also what? Converges. What can you also say then? If an diverges, what can you say about the bn? Bn is also what? Diverges. That's what they say.
So no matter what, they always, A and B always tend to do the same thing.
Exactly. That's what they're saying. It's, remember, this is a limit test, okay? You're doing a limit comparison test. So let's look at the example. When you look at the example, that makes sense. So I want to know about this series. All right, I want to know whether this converges or diverges. And they told you A and B, this number is not 0, so you know for sure denominator will not go to 0. All right, so I call it, this series is my A sub n, this is my B sub n. Okay, you know this series, this is a harmonic series, and we know this diverges. We know that, okay? This, we already know it's a divergent harmonic series, we know that. So we already know about this, I just don't know about this one, okay? So let's do the limit test. So this is what I'm doing. I'm gonna put, this is what I'm doing, in other words, limit n goes to infinity, a sub n divided by b sub n. That's what I'm doing. Sub a sub n is 1 over an plus b. The other one is what? 1 over n. All right, you multiply this together, then what do you get? This goes to denominator, that goes to numerator, so I have n over an plus b. That's all you have this. Is everybody with me? And then what I'm gonna do, we always do everything divided by n. Then you have, this just become a 1. And then divided by, that become a, b over n. But if you plug it in, n as infinity, this become a what? 0. So you just left with 1 over a. Right. So you got 1 over a, which is what? Some positive number. So then according to this theorem, if you have some positive number, what can I say? Either both converges or both diverges. So since this diverges, what can you say about this?
That it diverges as well.
Right, exactly. So that's called limit comparison test. Is everybody with me?
For now.
Okay. So I'm gonna finish this one and then we can look at some homework problems.
I think so.
So
Okay.
looking at this, they just giving you some guidelines. Okay, say look at this, look at that. When you compare, look at the leading term. So leading term has square, and then you think about the 1 over n squared because this one has 1 over something squared. So you compare this with this. Since this converges, this will be also what? Converges. This converges. So this will converge. This converges why? By the p series, right? Because p is equal to 2, which is bigger than 1. So you will series, it will converges. And this one you will compare with this, which is the same as 1 over n to the what? 1/2 power. Again, it's a p series, p equal to 1/2, which is less than 1. Then you're gonna say what? It diverges because p has to be greater than 1 to converges. So you know this will be also diverges. And looking at this, you got n squared and n to the 5th. So just thinking as n squared divided by n to the 5th, which give you what? 1 over n to the 3rd. So you compare with this one. Since p is equal to 3, bigger than 1, so you will what? Converges by p series. So we're done for the lesson today. So
Can
I
we go
can
back to slide 12? I got a question real quick.
which one?
Slide 12.
Slide 12. Okay, right here. Okay.
It was at the end, so I see how you got 1 over a.
Mm-hmm. Okay,
And,
you want me to go
okay.
over the algebra again? Okay.
No, man, I see how you got there. Okay, I was just trying to see how I'm supposed to know it like diverges.
Okay, because by this theorem says, if an divided by bn is n, which n is some positive number.
Mhm.
My case, this is some positive number because a is a positive number. They told you so. So I can just think of a equal to say, I can just say a equal to 4. Then 1 over 4 is definitely bigger than what? 0. So it's some positive number. According to this, if it's some positive number, all right, what can I say? They both either converges or diverges. And I know this diverges.